Call these ones a bit more complex. So learning goals, basically we're using the distributive rule to expand and then simplify, if we need to, expressions to make them expanded and then simpler. Success criteria. When you watch this video and then you participate in our next lesson, you'll be successful if you know how to apply the distributive rule and operations with like terms accurately. Let's look at the first one. It says expand the following and collect like terms. In part A here we see 2 minus 3x outside of x minus 4. We have to use the distributive rule and expand and then simplify. This one's a bit different because we have 2 here by itself and we're minusing off 3x minus 4. So we have to be very careful here. Everything past this line is subtracted from 2, so it operates like a negative. So I'm going to rewrite the question as plus negative 3 because it makes it obvious that everything there is acting like a negative. So I haven't changed anything else, I've just turn the minus into a plus negative. You should know by now that a minus can be written as a plus negative. So minusing a positive is the same as adding a negative. So I haven't changed it. I'll show you why I've done this. We can write the next line here as 2 plus. Now we can expand the negative 3 outside of x minus 4. Let's have a look. So we've got these green expansion arrows that go from the negative 3 to the x, so it's negative 3 times x, and the negative 3 to that minus 4. And from our previous work we know how to expand that. So what we do is show that negative 3 times x, and remember that is minusing a positive, so it's the same as plussing a negative, just like I showed before. So we have plus negative 3 times negative 4. Now remember, the 2 is separate to all of that stuff there, and we leave it till last, so this plus 2 just hangs on for now. Negative 3 times x is negative 3x, and plus negative 3 times negative 4 is positive 12. Two negatives times together make a positive. We just tidy this up. Now looking at the like terms, remember I said that's important, and we have like terms, 2 constants, 2 and 12, which we can simplify. There's no other x terms apart from the negative 3x there, so let's simplify that. So we have 2 plus 12 can go together, plus negative 3x. So tidying that up, we've got 14 minus 3x. Now you might not need to show all of these lines are working after you've done a few, but you probably should for the first few because they are more complex. Looking at the second one now, part B, we have 3 outside of x plus 2y minus 3x plus y. So what we have is 2 expansions. Everything from the right of this blue line is minused off, so we need to be careful with that. 3 outside of 3 outside of x plus 2y and minus everything else. That means plus negative plus negative 1 outside of 3x plus y. Now there is a 1 there. Don't forget that. 1 doesn't change anything, but there is a 1 there. So if we've got minus positive 1 we can change that to plus negative 1. It has the same effect. That actually makes it easier to get out. Let's have a look. Expansion arrows are in there, and you'll notice there are two parts to the expansion, a double expansion. Let's have a look at how this is done. The first one's probably pretty easy. 3 times x plus 3 times 2y is the first part. Plus sign in the middle. Negative 1 times 3x is negative 3x plus negative 1 times y is negative 1y, or just negative y. Simplifying now, let's have a look. We've got 3 times x is simply 3x. We've got 3 times 2y is 6y. Plus negative 3x is minus 3x. Plus negative y is minus 1y, or just y. We've got like terms. Let's put them together. We've got x's and y's. There we have the like terms put close together there. So put the x's together and the y's together. So we have 3x take 3x plus 6y take 1y. Easy now. So quite simply, 3x take 3x is 0, so we don't need to write that down. 6y take 1y, or just y, that's 5y. So all of that comes out as just 5y, which is surprising, isn't it? Because it's quite complex looking. So remember, we need to understand how we use the distributive rule and like terms accurately, which means we need to be careful of negatives at time in order to expand and then simplify. And you'd have to agree in this last one, 5y is a lot simpler than what we started with. Let's have a go at some